Class not yet started. Wait for 3-4 minutes. Until then, I'll switch off, stop video, and I'll mute. Good evening, students. Numerical methods. Just take the screenshots of this. After that, we can start. So for this is the civil syllabus, both for GATE and engineering services examination. For civil engineering students, all these topics are there in the syllabus. For mechanical engineering students, numerical integration will be the last topic. That is a trapezoidal and Simpson's rule will be the last topic for mechanical engineering students. In case mechanical engineering students are there in the class, you will have to sit in the class until this Simpson's rule is completed. Yeah. Okay. Yeah, okay. Until Simpson's rule is completed, then mechanical students can leave. For civil engineering students, all topics are there in the syllabus. For electronics, electrical and instrumentation engineering students, this is the Rangi Kutta's fourth order method. Electronics engineering, electrical engineering, instrumentation engineering students, this would be the last topic. For mechanical engineering students, Simpson's rule will be the last topic. For civil engineering students, all topics are there in the syllabus. Just to take the screenshots, we will start the subject. Take the screenshots. For civil engineering students, up to the last page. Up to all these topics are there in the syllabus for civil engineering students. So for civil engineering students, there should be around 3 to 4 marks weightage. For other branches, it should be around 2 marks, the weightage. Civil students, they have 3 to 4 marks weightage because they have extra topics. Now let us start the subject. What is the purpose of numerical methods? Listen to me, any mathematical equation, any type of mathematical equation, whatever it is, either it is a differential equation, integral equation, algebraic equation, transcendental equation, matrix problem, whatever it is, any mathematical equation whose solution cannot be evaluated directly. All that type of mathematical equations can be evaluated using numerical methods. Some of the mathematical equations cannot be evaluated directly. For example, look at this. Ln x minus cos x is equal to 0. What are the roots of this equation? Roots of this equation we don't know. Because suppose x square minus 5x plus 6 is equal to 0. What are the roots? 3, 2. We can find the roots of this equation using minus b plus or minus square root of b square minus 4ac by 2a. But we cannot find the roots of this equation in this manner. So unable to find the solution of mathematical equation, in all such cases, that type of mathematical equations solutions can be evaluated by using numerical methods. With the help of numerical methods, you will get the nearest possible solution. Whenever a direct solution is not possible, in such cases, we can find the nearest possible solution. That is the purpose of numerical methods. What is the first topic? Solutions of non-linear equations. Non-linear equations means what? Non-linear equations are 2 types. Topic number 1, heading solutions of non-linear equations. So non-linear equations 2 types. Either it is any equation, any algebraic equation whose degree greater than 1. Any algebraic equation whose degree greater than 1, that is a nonlinear equation. Any algebraic equation degree greater than 1, nonlinear equation. And the transcendental equation is also called nonlinear equation. So first of all, algebraic equation degree greater than 1 is a nonlinear equation. Transcendental equation is a nonlinear equation. First of all, what is algebraic equation? What is a transcendental equation? Any equation containing trigonometric functions or hyperbolic functions or logarithmic functions or exponential functions. One function that involves a trigonometric or hyperbolic or logarithmic or exponential, that type of functions are said to be transcendental functions. Algebraic function means polynomial function. Let us write the definition. There are two types of nonlinear equations. First type of nonlinear equation is algebraic equation. Second type of nonlinear equation is transcendental equation. Now let us see the definition of algebraic equation. Remember, x to the power of any real number, x power any real number is called algebraic equation. X power any real number. Write down. A polynomial equation in the form a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus an is equal to 0. But simply remember, x to the power of any real number is called an algebraic equation. X power real number is called an algebraic equation. Example number 1, 3x cube minus 2x square minus x minus 5 is equal to 0. X power 4 minus 3x square plus 1 is equal to 0. X cube minus 3x plus 1 is equal to 0. X to the power of real number, x power 0.2, that is also an algebraic equation only. X power any real number is called an algebraic equation. Now let us see the definition of transcendental So transcendental equation means any equation containing trigonometric function or hyperbolic function or logarithmic function or exponential function. That is called transcendental equation. Equations which involve transcendental functions like trigonometric, or hyperbolic, or logarithmic, or exponential, functions. Or exponential functions, etc. are called transcendental equations. Example, any equation containing trigonometric or hyperbolic or logarithmic or exponential function is called transcendental equations. These are the examples. So nonlinear equations can be evaluated using bisection method. Nonlinear equations means solutions of these types of nonlinear equations like transcendental functions or algebraic equations of degree bigger than 1 should be evaluated with the help of bisection, regular falsi, secant, and Newton-Raphson methods. Solutions of nonlinear equations can be evaluated using bisection method, regular falsi method, secant method, Newton-Raphson method. So before going to discuss about all these methods to find the roots of nonlinear equations like algebraic as well as transcendental functions, first of all, you people must know intermediate mean value theorem. Because with the help of intermediate mean value theorem only, we are able to find the roots regarding bisection and regular falsi methods. So that's why first we need to discuss intermediate mean value theorem. Intermediate mean value theorem. Before going to discuss about that, first you draw these diagrams. Once you draw these diagrams, you'll get clarity regarding the theorem. Draw the diagrams. This is y is equal to f of x. Y is equal to f of x is a continuous function and defined in closed interval AB. This is A, this is B. One endpoint of the curve is defined at A. So x coordinate is A. If I take x coordinate A, then y coordinate should be f of A. Another endpoint of the curve is defined at B. So if I take x is equal to B, then y coordinate should be f of B. First to just draw, after that I will explain the meaning of the purpose of intermediate mean value theorem. Sorry, don't draw the second diagram. So one edge of the curve that is defined at x is equal to A. Another edge of the curve defined at x is equal to B. So this is A. But this curve equation is y is equal to f of x. So y coordinate is f of A. Another edge of the curve defined at x is equal to B. So y coordinate is f of B. Next. One edge of the curve defined at x is equal to A, another edge of the curve defined at x is equal to B. So this is y is equal to f of x curve. This edge is defined at x is equal to A, so y coordinate is f of A. It is defined at x is equal to B. So y coordinate is f of B because y is equal to f of x. Draw this diagram also. one edge of the curve is defined at x is equal to a. Similarly, here also b. So this is a comma f of a. This point is b comma f of b. Now we write the theorem statement. Listen to me, everyone. This is the first quadrant. In the first quadrant, y coordinate is positive. This is the fourth quadrant. Fourth quadrant, y coordinate is negative. Fourth quadrant, y coordinate negative. Fourth quadrant, y coordinate is positive. Similarly, next, first quadrant, y coordinate positive. First quadrant, y coordinate positive. Fourth quadrant, y coordinate negative. Fourth quadrant, y coordinate negative. Now let us write the theorem statement. Look, everyone. Theorem statement is, suppose y is equal to f of x is a continuous function defined in closed interval AB. Suppose f of a and f of b are of opposite signs. Look there. F of a and f of b are of opposite signs. Then there exists at least one root between a and b. F of a and f of b are of opposite signs. Minimum one root lies between a and b. Minimum one root lies between a and b means curve will cross x-axis between a and b at minimum one point. If f of a and f of b are of opposite signs, then at least one root lies between a and b. Means curve will cross x-axis at least one point between a and b. Look at the second diagram and tell me the same statement then. Look here. The same statement can also be stated like this. F of a and f of b are of opposite signs. Then odd number of roots will lie between a and b. Odd number of roots. 1 root, 3 roots, 5 roots. The curve where it touches x-axis will be the required root. Curve where it crosses x-axis will be the required real root. So f of a and f of b are of opposite signs. Then minimum one root lies between a and b, or odd number of roots will lie between a and b. Means f of a and f of b are of opposite signs. Curve will cross x-axis at minimum one point between a and b, or odd number of points between a and b. Suppose f of a and f of b are of opposite signs, then no root lies between a and b. No root lies between a and b means curve doesn't cross x-axis between a and b. Or even number of roots lie between a and b. Even number of roots lie between a and b means curve will cross x-axis at even number of points between a and b. If f of a and f of b are of same signs, either no root lies between a and b or even number of roots lie between a and b. This is the theorem statement. Let us write that. Write down. Let y is equal to f of x be a continuous function defined on closed interval AB. First point, if f of a and f of b are of opposite signs, that is f of a and f of b less than 0. Remember, f of a and f of b are of opposite signs. f of a positive, f of b negative. Positive into negative, negative less than 0. F of a negative, f of b positive. Negative into positive, negative less than 0. Then either at least one root or odd number of roots lie between A and B. First diagram, second diagram will represent the first case. Now, if f of A and f of B are of same signs, that is f of A and f of B greater than 0, then either no root lies between A and B, or even number of roots lie between A and B. Even number of roots lie between A and B. But one thing everyone has to remember, this intermediate mean value theorem is valid only for single valued functions. It is not applicable for multi-valued functions. So what is single valued function? Single valued function means for one x value, there exists one and only one y value. For one x value, there exists one y value. That is a single valued function. If I take x is equal to 2, y is 4, x is 3, y 9. For one x, there exists one y value, that is single valued function. Multi-valued function means for one x value, there exists more than one y value. Suppose x is equal to 1, then y square is equal to 1, y is equal to plus or minus 1. So it is a multi-valued function. For one x value, there exists more than one y value, that is a multi-valued function. So intermediate mean value theorem is valid only for single valued functions. So remember that. Intermediate mean value theorem is applicable only for single valued functions. Now let us enter into the subject. This is the introduction. Let us start the subject. The first topic is bisection method. Topic number 1, bisection method. Bisection method is also called binary search method. It is also called Boolean's method. Bisection method, binary search method, also called Boolean's method, also called halving method. Halving method. Half continuous tense, halving. Half method. Why it is also called half method, we'll see. So draw the diagram. Intermediate mean value theorem, first diagram should only be drawn. Intermediate mean value theorem, first diagram. This is y is equal to f of x curve, which is defined in the continuous interval AB. One edge point is defined at x is equal to a, so y coordinate is f of a. Another endpoint is defined at x is equal to b, so y coordinate is f of b. In the first quadrant, y coordinate negative. In the fourth quadrant, y coordinate negative. First quadrant, y coordinate positive. Write that. Let y is equal to f of x be a continuous function defined on closed interval AB. Remember, f of a and f of b are of opposite signs. Then minimum one root lies between a and b, or even number of roots will lie between a and odd number of roots will lie between a and b. We have already seen here. Remember, here f of a is negative and f of b is positive. Remember, f of a and f of b are of opposite signs. Then the first approximation, f of a and f of b are of opposite signs. Then the first approximation is denoted by x1, defined as average of a and b. So remember, this is a, this is b. Remember, that's why it is called half method. F of a and f of b are of opposite signs. Then root lies between a and b. Once you confirm that root lies between a and b, means between a and b, curve will cross x-axis at some point. The point where curve can cross x-axis is the required root. So in numerical methods, we cannot get the answer directly. So that's why we need to find the first approximation, that is average of a and b, a plus b by 2. Immediately, first approximation is average of a and b, that is a plus b by 2, also denoted by x1. Immediately find out f of x1. Remember, immediately find out f of x1. Suppose f of x1 is equal to 0, then x1 will be the required root. Suppose f of x1 is not 0, then it should be either greater than 0 or less than 0. We don't know whether it is greater than 0 or less than 0. We are just assuming that f of x1 value, we don't know whether it is greater than 0 or less than 0. I am assuming it is less than 0. This is my assumption only. If you want, you can assume greater than 0 also. That is our assumption. In case f of x1 is less than 0, I mean negative. Remember, if f of x1 is negative, Here initially f of a and f of b are of opposite signs, then root lies between a and b. Now f of x1 is negative. If it is negative, f of x1 is negative, identify the latest positive sign. What is the latest positive sign? Latest positive sign occurs at b. If f of x1 is negative, identify the latest positive sign. Latest positive sign that occurs at b. Now tell me f of x1 and f of b. F of x1 and f of b are of opposite signs. So f of x1 and f of b are of opposite signs. That means root lies between x1 and b. Once you confirm that root lies between x1 and b, then the second approximation denoted by x2 defined as average of x1 and b. Average of x1 and b means x1 plus b by 2, and immediately find out f of x2. Suppose f of x2 is equal to 0, then x2 will be the required root. Suppose f of x2 is not 0, then it should be either greater than 0 or less than 0. We don't know whether it is greater than 0 or less than 0. Let us assume f of x2 is greater than 0. If you want, you can assume even less than 0 also. I mean negative also. If you assume f of x2 is negative, identify the latest positive sign. Latest f of x2, if it is negative, latest positive sign occurs at b. So f of x2 and f of b are of opposite signs. So root lies between x2 and b. x2 means what? Exactly middle point of x1 and b. x2 means exactly middle point of x1 and b. Now you observe, if I assume f of x2 is positive, where did you get the latest opposite sign? x1. Now f of x2 and f of x1 are of opposite signs. So root lies between x1 and x2. Root lies between x1 and x2. Therefore, the next approximation is average of x1 and x2. Average of x1 and x2 means once you confirm that root lies between x1 and x2, you observe f of x1 and f of x2 are of opposite signs. Root lies between x1 and x2. If root lies between x1 and x2, then this x1, x2, next approximation is average of x1 and x2. That is denoted by x3. So immediately calculate f of x3. Suppose we don't know whether f of x3 is positive. If f of x3 is 0, x3 will be the required root. Suppose f of x3 is not 0, then it should be either greater than 0 or less than 0. Suppose it is less than 0, negative, this is our assumption only. Then fourth approximation. Fourth approximation denoted by x4. F of x3 is negative. Where did you get the latest opposite sign? At x2. F of x2, f of x3 opposite signs. So root lies between x2 and x3. Root lies between x2 and x3. Now f of x2 and f of x3 are of opposite signs. Then the next approximation is average of x2 and x3. So we need to proceed in this manner. We need to continue so on. We need to repeat this procedure again and again and again until we get accurate answer. Till accuracy. Till accuracy means what? What do you mean by till accuracy? The difference between one approximation, the difference between one value minus its previous value should be less than or equal to epsilon. Epsilon means what? Any number very, very nearer to 0. The difference between one approximation and its previous approximation. One approximation, let it be n plus 1th approximation. Previous approximation is nth approximation. We have to repeat this process again and again and again until we get the difference between one approximation value and its previous approximation value must be less than or equal to epsilon. Epsilon means what? Epsilon is any number very, very nearer to 0. Until then, we have to repeat this process. Now, let us see note. So, before going to note, everyone has to remember just 1 minute. Rough estimation, because I want to discuss one conclusion. Listen to me, everyone. First time you said that root lies between. See, everyone, you observe that. First time you said first approximation is f of x1 and f of b are of opposite signs. So first approximation is f of a and f of b are of opposite signs. First approximation is a plus b by 2. A plus b by 2, exactly middle value. Now you are saying that f of x1 and f of b, f of x1 and f of b are of opposite signs. So root lies between x1 and b. Root lies between x1 and b. What is the length of this interval? Original length of the interval a comma b is b minus a, end point minus initial point. Now a plus b by 2, f of x1 and f of b are of opposite signs. So root lies between a and b. Now f of x1 and f of b are of opposite signs. Root lies between x1 and b. What is x1? Root lies between x1 and b. Original interval length b minus a. What is the length of x1 and b? X1 is the exact middle point. Be careful what I'm saying. X1 is the exact middle point. Full interval length b minus a. X1 is the exact middle point. So x1 to b. X1 is the exact middle point of a and b. AB length b minus a. Then x1 and b length is b minus a by 2. It is half of the interval because x1 is exactly at the midpoint. So x1b length is exactly half of the original interval length. And one more point, after that I will give a conclusion. Look here, this is important. Now f of x1 and f of x2 are of opposite signs. F of x1 and f of x2 are of opposite signs means what? Root lies between x1 and x2. Root lies between x1 and x2. See here, x1, x2. x2 is the middle point of x1 and b. x2 is the middle point of x1 and b. x1b length. x2 is the middle point of x1 and b. x1 comma b length is b minus a by 2. Now x2 is the exact middle point of x1 and b. So x1 comma x2 length, x1b length b minus a by 2, x1 x2 length is exactly half of b minus a by 2. Exactly half of b minus a by 2 means 1 by 2 into b minus a by 2. 1 by 2 into b minus a by 2. That is b minus a by 2 square. Remember original interval length b minus a. After the first interval, after the first approximation, interval length is b minus a by 2. After the second approximation, interval length is b minus a by 2 square. After the third approximation, interval length is b minus a by 2 cube. After the nth approximation, after performing n approximations, interval length is b minus a by 2 to the power of n. After doing first, second, third, fourth, fifth, n iterations, every time interval length, this is the interval length, every time interval length is exactly reduced by half of its previous interval length. B minus a by 2, b minus a by 2 square, b minus a by 2 cube. Every time interval length is exactly half. So after n number of iterations, you will get very, very, very small length of the interval. That very, very small length of the interval means it's after n number of iterations, interval length is very, very nearer to 0. That very, very nearer to 0, let it be epsilon. Epsilon means what? Any number very, very nearer to 0. So after n number of iterations, the error value or interval length is almost becoming 0.001 or even less than 0.001. So that 0.001, let it be epsilon. So write this point, note. Remember, what you need to remember is interval length is reduced exactly half after each iteration. So I will write like this. At each approximation, the length of the interval is reduced by half of its previous interval. Next, you can even write this. The error bound of bisection method is that means after n number of iterations, interval length is reduced by interval length is very nearer to 0 or even less than very nearer to 0, means let it be 0.001 or even less than 0.001. That 0.0001 is denoted by epsilon. After n number of iterations, interval length is becoming b minus a by 2 power n. N means what? Number of approximations, number of iterations. A, interval initial point. B, A means interval initial point, B means interval end point. N means number of iterations. Epsilon means what? Error value or accuracy value. The difference between one approximation and its previous approximation is 0.0001. Epsilon is that 0.001, that much accurate value. So sometimes in the examination, this epsilon value will be given, A and B will also be given. You will be asked to find N. N means number of iterations required. How many approximations we need to perform so that the error value should be epsilon or less than epsilon. The question can be expected like that in the GATE exam or engineering services exam. Then we can answer like this. That means we need to find N value from this formula. Write like this. Third point, the number of iterations required to reach an accuracy epsilon. We have formula is there. We have written in the second point, b minus a by 2 to the power of n less than or equal to epsilon. Now epsilon will go left side denominator, that is b minus a by epsilon less than or equal to 2 to the power of n. Now we need n value. That's why take logarithms both sides. Logarithm of b minus a by epsilon less than or equal to logarithm of 2 to the power of n. So logarithm of b minus a by epsilon less than or equal to n ln 2. So I can write like this, n ln 2 greater than or equal to ln b minus a by epsilon. So we need n value. This ln 2 will go right side denominator. ln 2 will go right side denominator. N greater than or equal to n greater than or equal to ln b minus a by epsilon divided by n2. You can write modulus or directly you can write bracket. Both are correct. This is the formula. Please do remember. Suppose in the examination you are asked to find how many iterations one has to perform, how many approximations required for achieving an accuracy of epsilon. Accuracy means not exact value. The difference between one approximation and its previous approximation is 0.001. Means that much accuracy value. Means error almost to zero. Then only you can use this formula. Moreover, you remember that bisection method, does it guarantee for convergence? Guarantee for convergence means guarantee for right answer. Bisection method guarantee for convergence means using this method definitely we get correct answer, because every time f of a, as you have already seen, every time interval length is exactly half. Finally it reaches one point. That point is the required root. So bisection method guarantees for convergence. Guarantee for convergence means guarantee for right answer. But it is a slow method. It consumes a lot of time to get the accurate answer. Genuine method, I mean we get accurate answers, but very, very slow method. That is the drawback. Bisection method, order of convergence is low. Slow rate of convergence. Write that. Rate of convergence means how fast. Rate of convergence means how fast it is coming close to the correct answer. That is slow. Slow method. Rate of convergence of bisection method is slow. Slow rate of convergence. Slow rate of convergence. And you remember, using bisection method, we can find only real roots. We cannot find imaginary roots. That is also only real roots can be determined. Means using bisection method, we are able to find only real roots. Only real roots can be determined. This is the story of bisection method. Now we do problems on bisection method. Don't worry, rate of convergence means not rate of roots calculation. How fastly it is coming close to the correct root. I will tell you, that is a concept. How fastly it is coming very close to the correct answer. How fastly it is getting. That is rate of convergence. The rate of convergence means fastness. Fastness of any one particular method can be determined using rate of convergence. That concept is there. I will teach it. See, day to day notes will be shared. Problems. Problem number 1. See, the purpose is whenever you are unable to find the roots, in all such cases, roots of that type of mathematical equations can be found with the help of bisection method, with the help of numerical methods. Any mathematical equation solution not possible directly. Analytical solution means a direct solution not possible, some formula procedure not possible. Then with the help of numerical methods, nearest possible solution can be determined with the help of numerical methods. That is the purpose of numerical methods. Different methods are there for finding different types of problems. Nonlinear equations can be found bisection, regular falsy, secant, Newton-Raphson method. Differential equations can be solved using Euler's method, Runge-Kutta methods. Integration problems cannot be evaluated, definite integrals cannot be evaluated directly. Then we can use trapezoidal and Simpson's method. Matrix problems can also be determined using Gauss elimination method, Gauss-Seidel method. Different procedures are there. Problem number 1. Problem number 1. Use the bisection method to find the third approximation for f of x is equal to root x minus cos x in the interval 0, 1. Remember, A and B. A means 0, B means 1. F of A, F of B, opposite signs. No, A means 0, B means 1. One suggestion, everybody, as far as getting first you write f of 0. Every trigonometric function value must be expressed its value in terms of radians. While you are calculating some trigonometric function value at some particular point, please convert your calculator from degrees mode to radians mode, unless otherwise specified in the examination. Because in the examination, they may specify your answer in terms of degrees. At that time only, you can write your answer in terms of degrees. Suppose they do not mention anything, you should always write your answer in terms of radians only, every trigonometric function value. I just need sign only. Bisection method needs only signs, values not required, only signs of the functions required. F of 0 minus 1, sign only required. Next, f of 1. So root 1 minus cos 1. Cos 1 you find in terms of radians. In terms of radians only. 1 minus cos 1 value in terms of radians you find. So f of 0 and f of 1 are of opposite signs. Therefore, remember, f of 0 and f of 1 are of opposite signs. Then the first approximation is average of 0 and 1. First approximation is average of 0 and 1, that is 0.5. Immediately find out f of 0.5. In case f of 0.5 is equal to 0, then 0.5 is the required root. Suppose f of 0.5 is not equal to 0, then tell me its value should be greater than 0 or less than 0. I mean positive or negative. Tell me f of 0.5, sign only tell me. Root of 0.5 minus cos of 0.5 in terms of radians only. Negative. Negative. Good, negative. Remember, if it is a negative, where did you get the latest positive sign? Latest positive sign occurs at 1. Occurs at 1. Now f of 0.5 and f of 1 are of opposite signs. F of 0.5 and f of 1 are of opposite signs. Then the second approximation is average of 0.5 and 1. Average of 0.5 and 1. That is 0.75. Immediately calculate f of 0.75. Suppose f of 0.75 is equal to 0, then 0.75 will be the required root. If it is not 0, then what is its value? Positive sign or negative sign? Only sign tell me. Good, positive. If it is positive, remember, if it is positive, you need to identify where did you get the latest opposite sign. Latest opposite sign at 0.5, negative. Old opposite sign don't consider. F of 0.75 positive. If it is positive, where did you get the latest opposite sign? I mean negative at 0.5. So f of 0.5 and f of 0.75 are of opposite signs. Therefore, next approximation means third approximation denoted by x3 defined as average of 0.5 and 0.75. After simplifying this, you will get 0.625. You are asked to find only third approximation. So you can try that. Problem number 2. The real root of the equation x e power x is equal to 1 between 0 and 1 obtained by using two iterations of bisection method is dash. Try yourself. You are asked to find the second approximation only. Answer is 0.75. The second approximation is. Next. Problem number 3. Only one of the real roots of f of x is equal to x power 6 minus x minus 1. Lies in the interval 1 less than or equal to x less than or equal to 2. And bisection method is used to find its value. For achieving an accuracy of 0.001, the required minimum iterations is this problem given in the GATE Electrical Engineering 2017. This is a 60-degree equation. So it will have 6 roots. Among those 6 roots, one root of this equation should lie between 1 and 2. And bisection method is used to find that one root. Now for achieving an accuracy means the difference between one approximation and its previous approximation should be less than or equal to epsilon. Epsilon value 0.001. So for achieving an accuracy of 0.001, how many minimum number of iterations should be used? How many minimum number of iterations must be used? Remember, to find the number of iterations, to find the number of required iterations for achieving an accuracy of epsilon, use this formula. N greater than or equal to ln b minus a by epsilon ln 2. Use this formula. N greater than or equal to ln b minus a by epsilon by ln 2. So ln greater b, a means interval initial point, b means interval end point. So a means 1, b means 2. Of course, epsilon value was also given to be 0.001. Now proceed. Substitute the information and let me know the data. So n greater than or equal to ln b minus a by epsilon 0.001 by So n greater than or equal to exact value, tell me 9 point. Exact value 9 point. Nine six. Exact value 9.96. So 9.96 iterations cannot be performed. So n greater than or equal to 10. N greater than or equal to 10 means we need to perform 10 iterations or more than 10 iterations. That means minimum number of iterations required. We need 10 iterations or more than 10 iterations, but minimum 10 iterations required. So in the same manner, note this and do yourself. We'll go to the next model then. Only one of the real roots of f of x is equal to x cube plus x plus 12 lies in the interval -3 less than or equal to x less than or equal to 2. And bisection method is used to find its value. For achieving an accuracy of 5 into 10 power minus 3, comma, the required minimum iterations is dash. So tell me the answer if you have already found anybody. Answer 10. I don't know the answer. That's why I'm asking. 9.96 means 10 only. 9.96 means 10. 9.96, make it as 10. No issue. We'll go to the next model now. Ten, fine. Next model. Regular falsy method. Or false position method. Or Method of tangents. Same bisection method diagram only you can draw. Draw the same diagram that we have written in bisection method. This is A. Same bisection method diagram. This is A comma f of A. This is B comma f of B. Bisection method diagram only. This is y is equal to curve equation. Let it be y is equal to f of x. Let y is equal to f of x. Be a continuous function y is equal to f of x is a continuous curve defined on closed interval AB. Look there, f of A and f of B are of opposite signs. If f of A and f of B are of opposite signs, remember in regular falsy method, here f of B positive in the fourth quadrant, y coordinate is negative. F of A and f of B are of opposite signs. In bisection method, the first approximation is average of A and B. Whereas in regular falsy method, if f of A and f of B are of opposite signs, be careful what I'm saying. In regular falsy method, if f of A and f of B are of opposite signs, then between A and B, curve, let it be capital A, let it be capital B. So curve AB is replaced by chord AB. Curve AB is replaced by chord, CHORD, chord. Chord means straight. Curve AB is replaced by straight line AB. This is curve AB. It is replaced by chord AB. If f of A and f of B are of opposite signs, between A and B, the corresponding curve is replaced by a straight line. Now, curve where it crosses x-axis will be the exact answer. But sometimes, suppose curve equation is ln x minus cos x is equal to 0. Its root means that curve where it crosses x-axis we don't know. In such cases, its root can be found approximately with the help of bisection or regular falsy method. Now that curve is replaced by a straight line. This straight line where it crosses x-axis will be the first approximation. The straight line where it crosses x-axis will be the first approximation. If f of A and f of B are of opposite signs, then curve AB is, this is curve AB replaced by straight line AB, is replaced by chord AB. Do you know this chord AB means straight line AB? Now you need to write the equation of the straight line AB. A straight line which is passing through x1, y1, x2, y2. What is the equation of the straight line passing through x1, y1, x2, y2? This is x1, y1. This is x2, y2. Equation of the straight line AB. Equation of the straight line formula y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. This is x1 y1. This is x2 y2. Substitute x1 y1, x2 y2. Y minus y1. Y1 means f of a. Y2 minus y1. That is f of b minus f of a. X minus x1. X1 is a. By x2 minus x1. This is x1. This is x2. Because x1 y1, x2 y2. X2 minus x1 means b minus a. Now you observe this straight line touching x-axis. Look here. This straight line touching x-axis at this point. The straight line where it touches x-axis will be your first approximation. Straight line touching x-axis at this point. So let this point be x1. On x-axis, y-coordinate 0. Straight line where it crosses x-axis will be your first approximation. It is touching x-axis at this point. Let it be x1. On x-axis, y-coordinate 0. This line meets x-axis at x1 comma 0. X coordinate x1, y coordinate 0. X coordinate x1, y coordinate 0. Substitute 0 minus f of a by f of b minus f of a. X coordinate is x1 minus a by b minus a. X1 is the first approximation. Look the diagram. X1 is the first approximation. FA means first approximation. Simplify and then find x1 from this. So b minus a will go left side numerator. Minus f of a by that is x1 minus a is equal to b into minus f of a, that is minus b f of a minus a into minus, that is plus a f of a by f of b minus f of a. Minus a will go right. So x1 is equal to minus b into f of a plus a f of a by f of b minus f of a plus a. Simplify this. X1 is equal to minus b into f of a. Now by taking LCM, it is a into f of b plus I am taking LCM. A into f of b minus a into f of a. Here plus a f of a, this is minus a f of a, cancel each other. Still we have a f of b minus b f of a. X1 is equal to a f of b minus b f of a. Is the first approximation. Remember, in the similar manner, we are able to find the second approximation, third approximation, etc., etc. So not required. In the same manner, we can prove the remaining results also. But in the examination, no need to remember this formula. Without remembering this formula, I will let you know how to find first approximation, second approximation, etc., etc. But the concept behind, let us see now. Look the diagram. F of A and F of B are of opposite signs. Then curve between A and B, curve is replaced by straight line. This straight line where it crosses x-axis will be your first approximation. This straight line crossing x-axis at this point, let this point be x1. On x-axis y coordinate 0. So x1 is the first approximation. At this point, at x1, come down perpendicularly. Don't raise the doubt. At x1, come down perpendicularly. At x1, if you can go up perpendicularly, you cannot reach the curve. That's why at x1, if you can come down perpendicularly, you can reach the curve at this point. From here, if you go up, you can't reach the curve. So from x1, if you can come down perpendicularly, you can reach the curve. So let this point be P. This point and this point, look this point is x1, this point also x1, because this point, both are at equidistant from y-axis. So this point x1, so y coordinate, if x is equal to x1, y is equal to f of x1. Now P x1 comma f of x1 still in the fourth quadrant. In the fourth quadrant, y coordinate negative. Be careful what I'm speaking. Earlier, f of A and f of B are of opposite signs. Then root lies between A and B. Now f of x1. Earlier f of A, f of B opposite signs, root lies between A and B. Now f of x1 and f of b are of opposite sides. So root lies between x1. This is x1. Root lies between x1 and b. x1 and b. So if root lies between x1 and b, then between x1 and b, curve should be between x1 and b, curve is pb. Curve should be replaced by chord pb, means straight line pb. Between x1 and b, we have curve pb. Curve pb will now be replaced by chord pb, straight line pb. This straight line pb, where it touches x-axis, will be your next approximation. This straight line pb touching x-axis at this point. This point will be your next approximation. Let this point be x2. x1 already completed. So on x-axis, y coordinate 0. So this is the second approximation. This is the second approximation at this point. So look here, A and B are the initial approximations. Initially, f of A and f of B are of opposite signs. So root lies between A and B. Later you said f of x1 and f of b root lies between x1 and b. Root lies between, initially f of a, f of b opposite signs. So root lies between a and b. Next you said f of x1 and f of b opposite signs. So root lies between x1 and b. Now you are saying a root lies between x2 and b. So grad x2 and b, next x3, here x3, here x4. This is this is a and b, this is x1 and b, next x2 and b, next approximation is x3 here, x4 here. Gradually we are coming very close to the root, means gradually we are coming close to the curve crossing x-axis. Curve where it crosses x-axis will be your first approximation, will be your next approximation. Next approximation x3 here, x4 here. Gradually we are reaching the root, means curve where it crosses x-axis. This is the purpose. I will let you know. Remember, using this method also we can find only real roots. We cannot find imaginary roots. Only the real roots can be located. We can't find imaginary roots. Moreover, does this method guarantee for convergence? Guarantee for convergence means guarantee for right answer. Guarantee for right answer. So this method guarantee for convergence. How can you say? First two, you are saying root lies between a and b. Next you are saying root lies between x1 and b. Next to x2 and b. Next x3 and b. Gradually we are coming close to curve crossing x-axis. So gradually we are coming to the root, means guarantee for convergence. Convergence means coming close to correct answer. Guarantees for convergence, only real roots can be located. Next, look here, the technique of finding the roots I will let you know. If A and B or you can write like this, if f of A and f of B if f of A and f of B are of opposite signs, then the first approximation is in the margin of your notebook, write like this, f of A and f of B are of opposite signs, root lies between A and B. F of A and f of B are of opposite signs, root lies between A and B. In the margin of your notebook, write like this, A here, B here, f of A here, f of B here. Because if root lies between A and B, write A here, B here, here f of A, f of B. Treat it as one 2 by 2 matrix determinant. Treat it as one 2 by 2 matrix determinant. Then the first approximation is x1 is equal to, what is the determinant of the matrix? These two product, A into f of A. These two product minus these two product. First approximation is A into f of b. Determinant of the matrix, these two minus these two product, minus b f of a by denominator is denominator, this value minus this value. Denominator is this minus this. Denominator is this minus this. This is the first approximation. Suppose root lies between a and x1, then you need to write a here, then you need to write x1 here. Here f of a here, f of x1 here. You can write x1 here, a here, or you can write b here, you can write a here, no issue. Suppose f of x1 and f of x2 opposite signs, you can write x1, x2 here, or x2, x1 here, no issue. x1, x2, f of x1, f of x2. Find the determinant value that is in the numerator. Denominator, this minus this. This is the way you need to find the each approximation and no need to remember any formula. Regarding this model, no need to remember any formula. We'll continue after the break. A break 15 minutes. We'll continue after the break. After the break, we do problems. I'm going to unmute. We'll do problems after the break. Welcome back to the session. Students, let us continue. We'll do problems now. Problem number 1. Use regular falsy method to find the second approximation for f of x is equal to x log x to the base 10 minus 1.2 between 2 and 3. Here 2 and 3 are the initial approximations. F of x is equal to x log x to the base 10 minus 1.2. So you only have to simplify and let me know the value. Remember, base of the logarithm is not mentioned. Always assume base e. If it is base 10, that must be clearly mentioned. Whenever base of the logarithm is not mentioned, then either you write ln or loz, that is base e only. I don't know, you only have to say the values of f of 2 and f of 3. In the examination, method name will be mentioned. You will be asked to solve one problem using bisection method or regular falsy method. Method name will be mentioned. F of 2, someone has given the answer, minus 0.597. F of 3, 0.23. So the first approximation is, remember and look here, f of 2 and f of 3 are of opposite signs. If f of 2 and f of 3 are of opposite signs, then root lies between 2 and 3. Once you confirm that root lies between 2 and 3, then you need to write 2 here, 3 here, and f of 2 here, f of 3 here. Find the determinant of this matrix. Means these two product minus these two product. Determinant of this matrix is x1 is equal to 2 f of 3 minus 3 f of 2 divided by, denominator is this minus this, f of 3 minus f of 2. Continuation I will write here. So x1 is equal to 2 into f of 3, 0.23, minus 3 into f of 2 minus 0.597 by f of 3 0.23 minus 0.597. Simplify this and let me know the value. Someone has found. Yes, good. 2.71 na 2.721 na. Please let me know the value. Different answers you are giving. 2.72. Is it correct? 2.721. Fine. And immediately find out f of 2.721. Suppose f of 2.721 is equal to 0, then 2.721 will be the required root. Suppose 2.7 f of 2.721 is not equal to 0, then tell me what is its value now. What is the value of f of 2.721? Not 0. Minus 0.017 or 16, both are correct, no issue. Minus 0.017 minus 0.0171 minus 0.017. 17. 3 decimal places more than enough. 3 decimal places. Now you observe earlier f of 2 and f of 3 are of opposite signs. Earlier f of 2 and f of 3 are of opposite signs. Now f of 2.721 is negative. F of 2.721 negative. If it is negative, where did you get the latest positive? Latest positive at 3. F of 2.721 and f of 3. F of 2.721 and f of 3 are of opposite sign. So root lies between 2.721 and 3. This is 2.721 and 3. This is f of 2.721 and here f of 3. If root lies between 2.721 and 3, write 2.721 here, 3 here. Or you can write 3 here, 2.721 here. No issue. Find the determinant of this matrix. These two product minus these two product. Denominator this minus this. So second approximation is x2 is equal to 2.721 into f of 3 minus 3 into f of 2.721 by f of 3 minus f of 2.721. This is 2.721 into f of 3. F of 3 0.23 minus 3 into f of 2.721 minus 0.017 by f of 3 0.23 minus 0.017. Simplify this and let me know the value. What is the answer for x2? 2.74. Good. 2.74. Fine. 2.74. Similarly, you note this and try yourself. Use false position method, comma, find a second approximation to the root of the equation x cube plus x minus 1 is equal to 0. Try yourself. Answer for this problem. Please verify and let me know. Around 0.49. I'm not sure about the answer. Please verify and let me know. Next problem. Problem number 3. Use regular falsy method to find a second approximation for f of x is equal to x log x to the base 10 minus 1.2. Sorry, 1 minute. Everything is okay except the function f of x is equal to cos x minus x e power x between 0 and 1. Answer 0.44673. Every trigonometric function value must be expressed in terms of radians. In the examination, you can solve the way we have solved previous problem. Next model. Secant method. And draw the diagram for this. See, not only in numerical methods, not only in mathematics, any subject, anywhere, through all problems of the gate examination, any trigonometric function, if you come across, Always express the trigonometric function value in terms of radians only. All problems in the GATE exam, including technical subject also, it should be expressed in terms of radians only. Suppose answer required in terms of degrees, in the examination they will mention. So you need to write your answer in terms of degrees. If required answer in terms of degrees in the exam, they will mention. If not mentioned means by default answer radians only. Draw the curve. Now this is the curve. Let it be y is equal to f of x curve. Instead of a and b, I am assuming this is x0, this is x1. Now this is x0 comma f of x0. This is x1 comma f of x1. Remember, in bisection and regular fallacy method, every time we are cross-checking f of a and f of b are of opposite sides. But it is not so in case of secant method. In case of secant method, it is not required to check f of a and f of b are of opposite sides. So what we do in secant method is, every time, first time you have to draw one secant line. Do you know, 1 minute, do you know chord? Chord means what? A straight line touches the curve at 2 points only. Straight line touches the curve at 2 points only is called chord. Secant line. What do you mean by secant line? A straight line touches the curve at 2 or more than 2 points. A straight line touches the curve at 2 points only, that is chord. A straight line touches the curve at 2 points or more than 2 points, that is called chord. C-H-O-R-D, chord. In secant method, what we do is, every time you have to draw one first secant line. Secant line means a line touches the curve at 2 points or more than 2 points. First secant line should be drawn passing through x0, x1. Next secant line should be drawn passing through x1, x2. Next secant line is drawn passing through x2, x3. Sequence only, x0, x1, x1, x2, x2, x3, so on. First secant line should be drawn passing through x0, x1. First secant line is drawn passing through x0, x1. This is x0, this is x1. This secant line where it touches x-axis will be your first approximation. It is touching x-axis at this point. So this is your first approximation. Now x0, x1 already completed. So this point, let it be x2. On x-axis, y coordinate 0. So this is x2 comma 0. We are assuming this is x2 on x-axis, y coordinate 0. At this point, come down perpendicularly, because if you can go up perpendicularly, we cannot reach the curve. So that's why come down perpendicularly. This point, and this point both are lying on the same line only. This point both are at equidistant from y-axis. That's why this point x coordinate, this point x coordinate same. This point x coordinate x2. So this point x coordinate also x2. Y coordinate should be f of x2. So what I said, every time you need to draw a secant line that should be passing through x0, x1. Next secant line passing through, first secant line should pass through x0, x1. Next secant line should pass through x1, x2. Next secant line should pass through x1, x2. This is x1, this is x2. Second secant line is passing through x1, x2. this. This is x1, this is x2. The line where it touches x-axis will be your next approximation. Already x0, x1 completed. This is x2, this is x3. At this point, come down perpendicularly. Now, what is this point? This point is x3 comma x3, and be careful what I'm saying now. Every time you need to draw one secant line, first secant line is drawn passing through x0, x1. Next secant line is drawn passing through x1, x2. Next secant line is drawn passing through x2, x3. Sequence only. Second, next secant line I am drawing passing through x2, x3. Be careful. This is x2, this is x3. I am drawing a secant line. Look, this is x2, this is x3. I am drawing a secant line passing through x2, x3. This secant line where it touches x-axis, secant line means a straight line passing through x2, x3. Where it touches x-axis? Here. That will be your next approximation. What is that? x4 on x-axis, y coordinate 0. Now, listen to me. Secant method does not guarantee for right answer. Reason is, look here everyone, secant method doesn't guarantee for right answer. Reason, every time you are drawing one secant line, now this secant line is passing through x2, x3. x2 and x3. This secant line where it crosses x-axis will be your next approximation, x2, x3. But here f of x2 and f of x3 both are in the fourth quadrant. In the fourth quadrant, y coordinate is negative. Y coordinate is negative. F of x2 and f of x3 both are in the fourth quadrant. In the fourth quadrant, y coordinate negative. Means f of x2, f of x3 having same signs. If f of x2 and f of x3 having same signs, then either no root lies between x2 and x3 or even number of roots lie between x2 and x3. We have already discussed in intermediate mean value theorem. Please verify the second point. Either no root lies between x2 and x3 or even number of roots will lie between x2 and x3. Which is correct? We don't know. That's why there is no guarantee that root lies between x2 and x3. Because every time you are drawing a secant line passing through x0, x1, x1, x2, x2, x3, x3, x4, sometimes f of x2, f of x3, or f of x3, f of x4 may lie in same quadrant whose y coordinates are same signs. Then no guarantee that root lies between x2 and x3. That's why secant method not guarantee for convergence. Right, like this. Let y is equal to f of x be a continuous function defined on closed interval x0, x1. Draw a secant line passing through x0 comma f of x0 and x1 comma f of x1. This line meets x-axis at x2 comma 0. X-axis at x2 comma 0. So x2 is the first approximation. Now another secant line should be first secant line passing through x0, x1. Next sequence A, x1, x2. Now draw another secant line passing another secant line passing through another secant line passing through x1, x2. x1 comma f of x1 and x2 comma f of x2. This line meets x-axis at x3 comma 0. This line meets x-axis at x3 comma 0. So x3 is the second approximation. So x3 is the repeat this process until we get accurate value. Repeat the process. Same. Next line should be drawn passing through x2, x3, x3, x4, x4, x5, so on until we get the required approximation, until we get the required root. See, the way we found equation of the straight line in regular falsy method, in the same manner, we can find the equation of the straight line in this method also. So that's why directly I'm giving the formula. Derivation is similar to regular falsy method only, equation of the straight line method only. The iteration formula is xn plus 1 is equal to xn minus 1 f of xn f of xn minus 1 by f of xn minus f of xn minus 1, where n is equal to 1, 2, 3, so on. Remember, x0 and x1 are the initial approximations. x2 will be the first approximation. To get x2, take n is equal to 1. To get x3, take n is equal to 2, so on. Derivation of the formula is similar to regular falsy method only. And no need to remember this formula also. The technique of regular falsy method formula, secant method formula, no need to remember. The technique of remembering, I will let you know. So simply forget that formula. Remember, in regular falsy method and bisection method, we can find only real root. Whereas in secant method, both real and imaginary roots can be found. We can find real roots as well as imaginary roots. Both real and imaginary roots can be determined this method doesn't guarantee for convergence. How many approximations required? Two initial approximations. X0 and X1 are the initial approximations. Two initial approximations needed. Means X0 and X1 are the initial approximations. Problems. No need to remember any formula. I will let you know. Look here. Suppose X0 and X1 are the initial approximations. Suppose X0 and X1 are the initial approximations. Here you write X0, here you write X1. Here f of X0, here f of X1. Treat it as one 2 by 2 matrix and find the determinant of this 2 by 2 matrix. These two products minus these two products divided by this minus this. So write down, if X0 and X1 are the initial approximations, initial approximations then the first approximation is X0, X1 initial approximations. So X2 will be the first approximation. What is X2 value? X0, X1 here, f of X0, f of X1 here. X2 value, these two products, that is X0 into f of X1 minus X1 into f of X0. Denominator this minus this. Suppose X1 and X2 are the initial approximations, write X1 here, X2 here. X2, X3 are the approximations, write X2 here, write X3 here. That is the way. Remember X0, X1 are the initial approximations, X2 will be the first approximation. Problems. This method we will not consider because we are not solving this method using intermediate mean value theorem. The approach in bisection and regular fallacy methods, we have used intermediate mean value theorem. But here we are not applying intermediate mean value theorem. The purpose, the method we adopted in this model is every time we are drawing a secant line passing through two latest values. Latest values means first line should be drawn passing through X0, X1. Some students, they're asking what is the difference between regular fallacy method and secant method. In regular fallacy method, if f of A and f of B are of opposite signs, you need to draw a secant line, you need to draw a line passing through A and B. Suppose f of B and f of X1 opposite signs, you need to draw a line passing through B and X1. Suppose f of X1 and f of X2 opposite signs, line should be drawn passing through X1 and X2. But here opposite signs don't consider. You just consider first line should be drawn passing through X0, X1. It doesn't matter whether f of X0, f of X1 same signs or opposite signs. Next line will be drawn passing through f of x1, f of x2. It doesn't matter whether x1, x2 having f of x1, f of x2 having same signs or opposite signs. Next line should be drawn passing through x2 and x3. It doesn't matter whether f of x2, f of x3 having same signs or opposite signs. In regular fallacy method, f of x2, f of x3 opposite signs, then only the line should be drawn. Write down. Find first two iterations of secant method for the following equations. With initial guesses problems solution. Write down f of x is equal to e power x plus sin x minus 4. Find f of 1. Sin 1 value in terms of radians. Tell me its value. F of 1. What is f of 1? Minus 1.264. Sin 1 in terms of radians. Sin 1 in terms of radians. How much? Minus 0.44. Is it correct? Minus 0.44. Fine. Tell me the value of f of 2. F of 2 is e power 2 plus sin 2 minus 4. Sin 2 value also in terms of radians. What is the next value? 4.2. 4.298. Please verify. You have to use CalC, virtual calculator you have to use in the exam, e power 2, small e value 2.718 power 2, sin t. You have to enter radians, and then virtual calculator you know how to. 4.298. Okay, fine. Next, in the margin of your notebook, write 1 here, write 2 here, if f of 1 and f of 2. Fine. See, in the this is x0, this is x1. Don't consider whether they have same signs, opposite signs, no issue. Directly x0, x1 here, f of x0, f of x1 here. For the next approximation, x1, x2, next approximation, x2, x3. Just to follow the sequence only. The first approximation is denoted by x2 because x0 and x1 are the initial approximations. x0, x1 are the initial approximations. So first approximation is x2. That is the determinant of this matrix. That is 1 into f of 2 minus 2 into f of 1 . 1 into f of 2, that is 4.298 minus 2 into f of 1 minus 0.44 by f of 2, 4.298 minus f of 1 minus 0.44. Simplify this and let me know the value. x2 is equal to how much? 1.0928 or 1.0928 or 1.093. Both are correct. 1.0928. Find out f of x2 means f of x2 is equal to f of 1.0928 minus 0.1291 minus 0.1291. Minus 0.1291. Now the first to secant line should be drawn passing through x0, x1. Next to secant line should be drawn passing through x1, x2. Here x1, here x2. What is x1? x1 is 2 given in the problem. Here x1, here x2. x2 means 1.0928. This is f of 2, this is f of 1.0928. Find the determinant of this matrix. These two product minus these two product divided by this minus this. First approximation is x2, second approximation is x3. So x3 is equal to 2 into f of 1.0928 minus 1.0928 into f of 2 by f of 1.0928 minus f of 2. Simplify this. X3 is equal to 2 into minus 0.1291 minus 1.0928 into f of 2, 4.298 by denominator minus 0.1291 minus f of 2, 4.298. Simplify this and let me know the value. You might have already found. So x3 1.1193, 1.119, 1.0928. Everything is correct. Now, in the similar manner, you can do the previous two problems also, next two problems also. I am giving you the answers here. The second problem answer 1.578707, 1.66016. Next 1.6 and 1.742268. Same manner, each and every step similar to the previous problem model only. Try yourself. Next. If we apply secant method, then the root of the equation x e power x is equal to 2. Between 0 and 1, after two iterations is. Try yourself it later. This is also similar to the previous problem model. Answer 1.839. 1.839. Sorry, 0.839. 0.839. Next model, most important and most expected topic in the examination, that is a Newton-Raphson method. Most important and expected topic, Newton-Raphson method. Newton-Raphson method is simply called Newton's method. Also called method of tangents. Remember, regular falsy method is called method of chords. We'll check what we have written there. Sorry. And everyone please verify, regular falsy method is called method of chords, not method of tangents. This is method of tangents. Newton-Raphson method, simply called Newton's method, also called method of tangents. This is most important and most expected topic for exam point of view. Very important. Even this problem, just 1 minute. Okay. Sorry, let me draw the curve. This is the curve equation. Let it be y is equal to f of x. Remember, bisection method, regular falsy method, secant method, two initial approximations required. But whereas Newton-Raphson method must need only one initial approximation. Be careful regarding Newton-Raphson method, initial approximation value. Not only Newton-Raphson method, bisection method, regular falsy method, secant method, Newton-Raphson method, initial approximation values must be given in the examination. So in Newton-Raphson method, we need to choose the initial approximation must be very nearer to curve crossing x-axis. What I said regarding Newton-Raphson method, we have to choose the initial approximation value must be nearer to curve crossing x-axis. It is nearer to the root. Nearer to the root means nearer to curve crossing x-axis. Now this point x0. So this point also x0, because this point both are lying on the same line only. So x coordinate x0, then y coordinate f of x0. What I'm saying is, regarding this model, first of all, you have to choose the initial approximation x0 value should be very nearer to curve touching x-axis. In the examination, this initial guess or initial approximation will be given in the exam. Now draw a secant line. Now we have to draw a tangent to the curve at the point. Draw a tangent to the curve at the point x0 comma f of x0. I have drawn a tangent to the curve at the point x0 comma f of x0. This tangent touching x-axis at this point, let this point be x1. I have drawn a tangent to the curve at the point x0 comma f of x0. This tangent touches x-axis at one point. Let that point be x1. On x-axis, y coordinate 0. So this is x1 comma 0. At this point, if you can come down vertically, you cannot reach the curve. At this point, if you can go up vertically, you can reach the curve. So at this point, I have gone vertically, I have reached the curve. So this point x coordinate x1. So from here, go vertically. So this point also x1 only, because this point both are lying on the same line. That's why this point also x1, y coordinate should be x1 comma f of x1. This point should be x1 comma f of x1. First tangent line is drawn at x1 x0 comma f of x0. Now you need to draw a tangent line to the curve. You have to draw one tangent to the curve at x0 here. Now draw another tangent to the curve at x1. Draw another tangent to the curve at x1 here at x1 comma f of x1. At this point I have drawn a tangent to the curve. It is touching x-axis at the point x2. On x-axis y coordinate 0. So this is x2 comma 0. So x0 is the initial approximation, x1 is the first approximation, x2 is the second approximation. Gradually we are coming close to the curve where it touches x-axis. x3 third approximation. After 3-4 iterations we can come very close to curve touching x-axis. I don't. Let y is equal to f of x be a continuous function. Choose the initial guess. Initial guess means initial approximation only. Choose the initial guess x0 nearer to the root. Remember, consider the initial approximation or initial guess same. Choose the initial approximation x0 nearer to the root. Nearer to the root means nearer to curve crossing x-axis. Draw a tangent to the curve y is equal to f of x at the point x0 comma f of x0. I have drawn a tangent to the curve at the point x0 comma f of x0. What is the equation of the tangent? We have drawn a tangent to the curve at x0 comma f of x0. So equation of the tangent is tangent equation formula y minus y naught is equal to m into x minus x naught. Y minus y naught. Y naught means f of x naught. Y naught, x naught comma y naught. A tangent passing through the point x naught comma y naught. Y naught means f of x naught is this. So this is the equation of the tangent passing through x naught comma y naught. But in our problem, y naught means f of x naught. Just 1 minute. M means slope. Slope of the tangent is also denoted by dy by dx. M means slope. Slope also denoted by dy by dx. We have drawn a tangent to the curve at the point x0 comma f of x0. So slope required at x naught comma f of x naught into x minus x naught. So this is y minus f of x naught. Look there, y is equal to f of x. dy by dx is equal to f dash of x. At x coordinate x naught only. X coordinate x naught required, y coordinate not required because we have x only. Take x is equal to x naught. This is the equation of the tangent passing through the point x naught comma y naught. But one thing you remember, this tangent touches x-axis at which point? x1. Means what? x1 comma 0. This tangent touches x-axis at x1 comma 0. So x coordinate x1, y coordinate 0. Substitute x coordinate x1, y coordinate 0 here. So 0 minus f of x naught is equal to f dash of x naught, x coordinate x1. So the curve where it touches x-axis, it will be the first approximation, the tangent touching x-axis at x1. So x1 is the first approximation, x2 second approximation, so on. So from this, x1 minus x naught is equal to minus f of x naught by f dash of x naught. From this, x1 is equal to minus x naught will go right. So it is x naught minus f of x naught by f dash of x naught. But this formula is applicable only when f dash of x naught not equal to 0. This is the first approximation. x1 is the first approximation. Guess the second approximation now. First approximation x1 is equal to. Second approximation x2 is equal to. First approximation x0 minus. Second approximation x1 minus f of x1 by f dash of x1. But this is valid only when f dash of x1 not equal to 0. Third approximation x3 is equal to x2 minus in the same manner we just guessed the third approximation also. Now we guess first approximation is x1, second approximation is x2, third approximation is x3. N plus 1th approximation N plus 1th approximation is xn plus 1 is equal to xn minus f of xn by f dash of xn, where f dash of xn not equal to 0. note. Write down. Here also we can find both real and imaginary roots. Both real and imaginary roots can be determined. Next, Newton-Raphson method will be convergent if. When the Newton-Raphson method will be convergent? Listen to me. If f dash x value not equal to 0, f dash x is equal to 0, something by 0, infinity, undefined, then method will not be convergent. Moreover, look here. The Newton-Raphson method converges only when the initial approximation is very, very nearer to the root. Suppose this initial approximation is far from the root, it is very, very far from the root. Root means curve crossing x-axis. If initial approximation is far from the root, at this point, if you can go up or if you can go down, you cannot reach the curve. If you cannot reach the curve, how can you draw a tangent? So that's why initial approximation value must be very, very nearer to root. Root means curve crossing x-axis. I don't. The initial guess is nearer to the root. Next, just 1 minute. Write down f dash x not equal to 0. Next, Newton-Raphson method will not be convergent. Newton-Raphson method will not be convergent if f dash x is equal to 0. F dash x is equal to 0 means something by 0, infinity, undefined. One more thing is, initial approximation is far from the root. If initial approximation is far from the root, there if you can go up or go down, you cannot touch the curve. Note down. Students, tomorrow schedule morning 9 a.m. to 1:30 p.m. Geotech for regular batch students. For regular batch students, all regular batch students. Tomorrow 9 a.m. to 1:30 p.m. Geotech for regular batch students. 2021 regular batch students. 20. This is another one. 2020 regular batch students. Afternoon 2:30 p.m. to 5 p.m. environmental engineering. This environmental engineering, those for the students, when it is for the students, those who it is not completed, they can attend 2:30 p.m. to 5 p.m. But the link will be provided to the students, those who, for them environmental engineering is not completed. So the students, whoever they get the link for environmental engineering, they can link for the environmental engineering, they can attend afternoon 2:30 to 5 p.m. Daily evening 5:30 to 9, our numerical method session will go continuously 4 days. for civil engineering students. And day after tomorrow, not tomorrow, day after tomorrow, morning 7 a.m. to 9 a.m. Geo topic, new topics. Geotech, new topics. Day after tomorrow, morning 7 a.m. to 9 a.m. Geotech, new topics. For all GATE 2021 students, inform your friends also. Day after tomorrow, morning 7 a.m. to 9 a.m. Geotech, new topics only. For all GATE 2021 students, please tell your friends. Hello? Hello, Shiva. Hello? Phone చేసావా? Hello? The syllabus is both for GATE and ESC. GATE and ESC, the syllabus not only for GATE. Some students asking what about ESC students. This is both for GATE and ESC. The numerical methods class, geotech class, and all subjects, and environmental engineering both for GATE and ESC. Okay, na? Syllabus both for GATE and ESC. Let us continue. The initial approximation is far from the root. Remember, if f dash x is equal to 0, this method fails. If Newton-Raphson method fails, use regular falsy method. If Newton-Raphson method fails, then the regular falsy method should be used. Reason, if Newton-Raphson method fails, next method is secant method, but we can use secant method. But secant for right answer. That's why we cannot use secant method. Next, we can use regular falsy method and bisection method. When compared to regular falsy method, bisection method, regular falsy method is a little bit faster method. That's why whenever this method fails, you need to use regular falsy method. For 2022 batch students and for 2021 batch students, evening 5:30 to 9, regular as usual, numerical methods class will continue. Geotech means geotech for students. Write down. See, using Newton-Raphson method, square root, cube root, square root, cube root, etc. means square root of a number, cube root of a number, and fourth root of a number. Everything can be determined using Newton-Raphson method also. Square root, cube root, etc. can be determined using Newton-Raphson method. It is very, very important. Directly in the GATE examination, several times we were asked, what is the square root of a number of Newton-Raphson method iteration formula? What is the iteration formula for cube root of a number, for fourth root of a number, etc., etc. So one formula I will derive. In the similar manner, you can prove the remaining formulas. I will show you. One formula I will derive. Remaining you have to. In the examination, several times we were asked what is the square root of a number iteration formula, cube root of a number iteration formula. How do you get root n? To get root n, listen to me. To get root n, you need to solve x square minus n is equal to 0. So x square is equal to n. So x is equal to root n. To get root n, we need to solve x square is equal to n or x square minus n is equal to 0. So therefore, to find square root of a number, the corresponding algebraic equation is x square is equal to n, or x square minus n will be the corresponding algebraic equation. Let f of x is equal to x square minus n. Then what is f dash of x? 2x. What is the Newton-Raphson iteration formula? xn plus 1 is equal to xn minus f of xn by f dash of xn. F of xn. Substitute x is equal to xn here. F of xn is equal to xn square minus n. F dash of xn is equal to 2 into xn. So take LCM. Xn into 2xn. 2xn square minus of xn square minus n by 2xn. So 2xn square minus xn square, that is xn square, minus into minus, that is plus, by 2xn. Split that. Split this. Xn square by 2xn, that is xn by 2, plus capital N by 2xn. What is the common factor? 1 by 2. So xn plus 1 is equal to 1 by 2 into xn plus capital N by xn. This is the iteration formula for square root of a number. In the examination, we were asked what is the Newton-Raphson iteration formula for root of n. Then you will have to use this. Root n. Root n corresponding polynomial is x square minus n. X square is equal to n, or x square minus n is equal to 0. What is the iteration formula? One by 2 into xn plus capital N by xn. Similarly, you can guess what is the iteration formula for cube root of a number? Square root of a number is x square is equal to n. Cube root of a number is x cube is equal to n. Corresponding polynomial is x cube minus n is equal to 0. Substitute 2 is equal to 3. For square root, it is 1 by 2. For cube root, it should be 1 by 3. For square root, it is 1xn. Remember, for square root, it is 1xn. So for cube root, it should be 2xn. For square root, denominator is xn power 1. For square root, denominator is xn power 1. For cube root, denominator is xn power 2. Fourth root of a number, x power 4 is equal to n. X power 4 minus n is equal to 0. Corresponding algebraic equation. This is 1 by 2, 1 by 3. Now it is 1 by 4. Here this is 1xn, 2xn. It should be 3xn plus capital N by xn cube. Similarly, generalized form, pth root of a number. Pth root of a number, that is x power p minus n is equal to 0. Square root 1 by 2, cube root 1 by 3, fourth root 1 by 4, pth root 1 by p, 1xn, 2xn, fourth root 3xn, fifth root 4xn, pth root p minus 1 into xn plus capital N by xn power p minus 1. Inverse of a number. Newton-Raphson iteration formula for inverse of a number. Corresponding polynomial is 1 by x is equal to n. So x is equal to 1 by n. So this is 1 by x minus n is equal to 0. The corresponding iteration formula is xn plus 1 is equal to 2xn minus nxn square. These are the formulas. Among all models of these four methods, bisection, regular falsies, secant, and Newton-Raphson methods, the most important and most expected topic in the examination is Newton-Raphson method. Tomorrow we will do problems on Newton-Raphson method. If students have any doubts, you can talk to me now. Have any doubts, you can talk. Tomorrow we will do problems on Newton-Raphson method. Students, any doubts? Nunavad Dasu.
Sir, good morning, sir.
Tell me.
Sir, my doubt is not about. My doubt is not about your subject, sir.
Tell me.
But they didn't cover the strength of metal and engineering mechanics, sir.
Your strength of materials not yet completed, huh?
Yes, sir.
Your batch?
Batch 2021, sir.
2021 gate, na?
Sir, 2021-21.
That is 2021 gate, huh?
Yes, sir.
Okay. Not yet completed, huh?
Yes, sir.
So I'll inform. Okay.
Okay, sir. Thank you, sir.
Your batch number? I mean, batch 2, batch 3, like that, your batch?
Sir.
KTGM 2, sir.
Sir. I'm Shiva, sir.
Hello. Shiva చెప్పు వాళ్ళకి.
వీళ్ళకి ఇప్పుడు ఈవినింగ్ న్యూమరికల్ మెథడ్స్ అయిపోయిన తర్వాత మేబీ సండే ఆర్ మండే నుంచి మార్నింగ్ ఒక సబ్జెక్ట్ ఈవినింగ్ ఒక సబ్జెక్ట్ స్టార్ట్ అవుతుంది సార్. ఒకటి ఇంజనీరింగ్ మెకానిక్స్, స్ట్రెంత్ ఆఫ్ మెటీరియల్స్.
స్ట్రెంత్ ఆఫ్ మెటీరియల్ ఏమని చెప్పంటావు రఫ్ గా?
మేబీ సండే ఆర్ మండే.
అదే
నెక్స్ట్ వీక్ లో పక్కా స్టార్ట్ అయిపోతాయి 2 సబ్జెక్ట్స్.
స్టూడెంట్స్ నెక్స్ట్ వీక్ other subject will be started, either strength of materials or some other subject. They will let you know, they will announce.
Okay, sir. Thank you, sir.
Okay. Any other doubts regarding the subject? Students, any doubts regarding the subject? Because I'm going to end the session. Numerical methods different, numerical ability different. Numerical ability means that is aptitude. Numerical methods means this is maths. IN means instrumentation engineering students. Geotech, that is there for civil engineering students, not for instrumentation engineering students. Okay, nobody is there. I'll be going to end the session. All methods will not give the same answer, Mr. Brajesh Pandit. Different methods will give different answers, but all answers little bit different only between the answers. But among all methods, Newton-Raphson method is the most efficient method and most accurate answer you will get using Newton-Raphson method. All methods will not give same answer. Almost same answers, there would be a little bit difference. Mohan, unmute yourself. Mohan.
Sir.
Tell me.
Sir, 1 by n square unnappudu sir.
1 by n square also we can find in the same manner. 1 by n square, how do you get to get? See, students, I will provide the notes for numerical methods that your concerned Shiva sir will provide the notes by tomorrow morning. I will upload and I will send the sketchbook file they will provide. What you are asking, Mohan? 1 by n square?
Yes, sir.
How do you get 1 by n square? By solving which equation you get? To get 1 by n, no, you need to solve 1 by x minus n is equal to 0, right? So 1 by x is equal to n. So x is equal to 1 by n. How do you get 1 by n square? Tell me. 1 by n square means 1 by x square is equal to n. No, you are not getting 1 by n is equal to x square. To get 1 by n square, what is the first you need to write the corresponding algebraic equation. Tell me the corresponding algebraic equation. One by x minus n square is equal to 0. Then 1 by x is equal to n square. Then x is equal to 1 by n square. Now this is the corresponding algebraic equation. So f of x is 1 by x minus n square. F dash x is minus 1 by x square, and then substitute. Anything can be found. Is it clear?
Yes, sir.
You can try, you will get. Otherwise, I will show you because other students are waiting in the queue to answer. That's why. Can you solve?
Yes, sir.
Try. If you do not get, tomorrow I will let you know. This is the function. To get n square. See, remember to get 1 by n square. 1 by n square, 1 by x minus n square is equal to 0. To get 1 by n cube, 1 by x minus n cube is equal to 0. Corresponding algebraic equation. Okay?
Okay, sir.
Any doubt regarding this? Tell me. Huh?
No doubt, sir. If I have any doubt, I will let you know tomorrow, sir.
You can try in this manner and just get it to my notice if you are unable to get the solution then. Next, anybody?
Okay, sir. Thank you, sir.
Okay, welcome. Any students, I'll be going to end the session. If anybody is there, please raise hands. Please unmute yourself and talk to me.
Sir, open the problems on second method.
A little bit loud. Hello? 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 Mr. Alaya, is it audible? Your voice is not audible. Yallaya Tekurapalli. Little bit loud. You can speak. Hello. Hello. Tell me.
Hello, sir.
Tell me. Tell me. Are you talking? Please unmute yourself, Mr. LA, and then talk. Notes will be provided. Why you are worrying? Students, Mr. Ash Patel, ESC previous questions also tomorrow. Actually, till now, from these three models, whatever the models, Mr. Ash Patel, bisection method, regular falsy method, bisection method, regular falsy method, Newton-Raphson method, bisection, regular falsy, secant method, ESC previous questions till now not given. That's why I did not solve. Mr. Ash Patel, from tomorrow, Newton-Raphson method, by Newton-Raphson method, ESC previous gate questions are there, we will teach. Actually, the bisection, regular falsy, secant, only few problems were given in the gate. From Newton-Raphson method onwards, several problems were given in the gate and ESC, we will discuss in the class then. Mr. Alaya, my voice is not audible. Tell me. Students, my voice, is it audible? Okay. Yes. Please unmute yourself, Mr. Alaya. Unmute yourself and then talk. You are not unmuted. Tell me, now it is. Hello? Yalaya, please talk to me. Ash, Mr. Ash.
Hello, sir.
Tell me a little bit loud.
I'm audible, sir.
Yes, yes.
Sir, that secant method problem 1. Can you open this slide, sir?
Slide you want?
Yes, sir.
This
Sir,
one,
yes, sir. That's second approximation. Sir, here 1.0928 in first place and 2 in second place, na, sir.
1.0928. I didn't get what you are asking. Hello?
Sir, that 1.0928 value is x naught and that 2 value is x1, na?
Just 1 minute. Look here. Here first x0, x1 here. Here x0, x1 here. Next x1, x2. Here x1, x2. What are x0, x1? This is x0, x1. For first approximation, you need to take x0, x1. For second approximation, you need to take x1 and x2. x0 and x1. Look there. x0, x1. Is it clear?
Yes, sir.
Now, for the next approximation, x1, x2. What is x1? x1 is 2. x1 is 2. x2 is 1.0928.
Okay, okay, sir. Okay, sir.
For the next approximation, at this place you need to write x2, here x3. For next approximation x3, x4. For next approximation x4, x5. Next x5, x6. Next x7, x6, x7.
Yes,
Is
sir.
it clear?
Okay. Yes, sir. And I understand, sir.
Okay.
Thank you, sir.
Please mute yourself. Mr. Alaya, it was completed or not? You are not unmuting yourself. Please unmute yourself. Talk to me. Alaya, it is audible. Tell me. There may be some problem from your side. Everything is clear here. I gave my mobile number. You can talk to me if you have a doubt. Mr. Alaya, first of all, you did not unmute yourself. Okay, I'm going to end the session. Your voice is not audible. You can talk to me. I gave that number. You can call. I'm going to end the session.